Consider an area A, which is part of a sphere of radius r. Imagine a sphere like a ball and take a small part of its surface. This small part is what we call area A. The radius r is the distance from the center of the sphere to any point on its surface. To find the solid angle subtended by this area at the center of the sphere, we are trying to measure how large this area A appears from the center of the sphere, point C. This is what we call the solid angle. Now, we let point C be joined to every point on the edge of the area A. Picture drawing lines from the center of the sphere, point C, to the edges of the area A. These lines form a cone shape. The angle enclosed by the cone at point C gives the solid angle. The size of the cone's opening, as seen from point C, is the solid angle. It's like looking at a slice of pie from the tip of the slice. The value of the solid angle is given by this. A over r squared is the radian. The formula to calculate the solid angle is the area A divided by the square of the radius. This gives the solid angle in a unit called steradians. Steradians are to solid angles what degrees are to regular angles. The unit of solid angle is steradian. Just as we measure flat angles in degrees or radians, we measure solid angles in steradians. If in the above equation A is equal to r squared, then this one will be equal to steradian, 1 steradian, sorry. If the area A equals the square of the radius r, then the solid angle is exactly 1 steradian. This helps us understand that 1 steradian is the angle formed by an area on the sphere that is the same size as the square of the radius. Hence, steradian is defined as the angle subtended at the center of a sphere by a part of its surface having an area equal to the square of the radius of the sphere. In simpler terms, a steradian measures how big a piece of a sphere looks from the center. If you cut out a piece of a sphere that has an area equal to r squared, the angle it makes from the center is 1 steradian.